At 2:14 p.m. on October 24, 1986, lake water in Cameroon's volcanic crater suddenly turned blood red, releasing a dense, invisible vapor that suffocated 1,746 people and 3,500 livestock in under 20 minutes without a single drop of rain. How did a peaceful tropical lake quietly store 1.2 million tons of lethal carbon dioxide? Why did a tiny ripple trigger a catastrophic tectonic burp? And what modern engineering marvels are now desperately trying to degas the deep abyss before it happens again? Deep beneath the Oku volcanic field, subterranean magma chambers constantly leak mantle-derived gases directly into the hypolimnian layers of freshwater lakes like Nyos and Manaun. Unlike typical surface water turnover that happens seasonally in temperate zones, equatorial lakes remain thermally stratified year-round, trapping dense mineralized fluids under immense hydrostatic pressure at depths exceeding 200 meters.
The water held a sleeping giant, pressurized by the crushing weight of the abyss.
On the fateful night at Lake Nyos, an estimated 300 cubic centimeters of gas per liter of water rapidly broke solution, forming a high-velocity geyser that propelled a column of water 80 meters into the air. The resulting cloud of carbon dioxide, weighing approximately 1.6 million metric tons, was denser than ambient air, causing it to hug the ground and flow down adjacent valleys in two distinct streams up to 50 meters deep. As the dense invisible current advanced at speeds of 20 to 50 kilometers per hour, it displaced all atmospheric oxygen, instantly shutting down cellular respiration in every living mammal caught in its path. Survivors reported smelling an unusual odor resembling gunpowder or rotten eggs, though pure carbon dioxide is entirely odorless, an olfactory hallucination likely triggered by trace amounts of hydrogen sulfide and sulfur dioxide mixed in the plume. Autopsies performed by international medical teams revealed classic signs of asphyxiation and severe pulmonary edema, with victims collapsing instantly while walking, working, or sleeping in their beds. Government ministers and volcanologists from the Smithsonian Institution rushed to the site within 48 hours, collecting water samples that showed near-zero dissolved oxygen levels and pH values plummeting to acidic extremes. Just 8 years prior, in August 1984, a nearly identical Limnic eruption at nearby Lake Manaun had claimed 37 lives, yet warning signs were tragically misinterpreted as local folklore or supernatural phenomena. Limnologists Sigurdsson and Kling published groundbreaking research in Nature, formally defining these rare events as Limnic eruptions and calculating that Lake Nyos was recharging its gas quota at a rate that guaranteed another explosion within decades. To prevent a recurrence, an international consortium designed an ambitious mitigation project in 2001, installing a polyethylene pipe anchored vertically in the deepest part of Lake Nyos to act as an artificial trigger. Once primed using a water pump, the self-sustaining siphon draws carbon dioxide-rich water from 208 meters depth, allowing dissolved gas to expand and escape safely into the atmosphere as a controlled fountain. By 2011, engineers added 2 more pipes to Lake Nyos and successfully lowered the dissolved gas volume below the critical threshold, reducing the hydrostatic pressure by over 50%. However, neighboring Lake Kivu on the border of Rwanda and the Democratic Republic of Congo holds an estimated 250 cubic kilometers of dissolved carbon dioxide alongside 60 billion cubic meters of methane gas. Nature keeps volatile secrets locked beneath placid surfaces, waiting for the slightest disturbance to turn life-giving water into an invisible breath of death.